Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome everyone to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are visiting with Greg Budzynski, the founder of IT OT Systems. And we're going to be chatting about something that, now you probably have heard the acronym, but a deeper dive into what are PCLs, or programmable. I'm going to trip over this, Greg, so just correct me if I really mess it up. Programmable Logic Controllers, or some people refer to them as PACs, Programmable Automation Controllers. So welcome to the show, Greg.
Hi, good morning, Susan. Thank you for the opportunity to be here. PLCs, Programmable Logic Controllers, Programmable Automation Controllers, they are the heart of any automation process within a water, wastewater treatment facility or any industrial control system, really.
So what exactly do they do? Is it software? Is it hardware? For those who may not be familiar with the term, or, oh yeah, I've heard of that, but have no idea what it is, where it sits, how it operates. Yeah, give us a real layman's 101 on that.
Yeah, so going all the way back to the actually late 60s, GM actually went out to contract with any vendor that was willing to bid on the project and requested a piece of hardware that was reprogrammable to automate their assembly lines. And so a programmable logic controller does exactly that. It runs an application in the field, or in the new terms of at the edge, of being able to run an application out in the field as close to the devices as possible. So if you have a process control situation, you have a need for running an application that can perform logic, that can call pumps to run, change the speed that they're running at, modulate the valves as you need to, because you can't have operators running around, especially at larger facilities, performing all of these actions. So a programmable logic controller has the four resources that you need for running an application. You need a compute resource, you need memory, you need storage, and then lastly, of course, you need communication. And communication being obviously critical, where any application that runs that's going to be useful has to be able to talk to A, the devices, and B, the operators who are providing the supervisory control.
Okay, so how does having all these little things in place, how does it actually on a plant level make an operator's life easier?
So anytime you automate the boring stuff is one of the best books that you can read, is automate the boring stuff. Automate the things that are just the menial tasks that a person would atypically have to go out and perform. So if you have a routine that is either continuous or periodic that needs to be performed, as far as an action within the field, like modulating a valve or operating the level of a scum pump based on variations that happen in the flow of your facility, then you want to be able to automate that. You don't want to necessarily have this dependency on an operator to go out and perform those actions in order to make sure that your facility functions in an optimal fashion. So a PLC or PAC, and sometimes they're also called DCS controllers, and we can get into that in another podcast, but distributed control systems are a collection of PLCs. But a PLC performs this function by operating your field devices and monitoring your field devices in order to make that happen within your facility.
So are most devices equipped to be able to be operated automatically in a plant? Or is this also used as a flag when an operator needs to go out to that device and make the changes that are necessary?
Yeah, you have both cases. So what you call traditional I/O was all leveraged through physical electrical connections, where you have monitoring of a voltage to provide a discrete input, or even sometimes an analog input, as you would call it, or possibly the current coming from a device. And each device in the field would provide an input back to the controller for that controller to be able to make an action on a field device, another field device, based on the conditions that are around the facility. Now, not all devices within the facility have this automation. That's where you have things like hand valves, and it is a much more costly implementation to be able to do that, because you need to have the electrical connections, you need to have a smarter device. And we're getting into this world now where we have smart devices. And those devices communicate even at a higher level, from this simple electrical connectivity to what you could call a bus communication network, or even an Ethernet network, where you are able to monitor every bit of status from that device. And that has really exponentially increased the amount of data points that you can get from either the device itself or from the field. And that really leads us to a better capability of being able to do asset management, to perform operational excellence execution within the field devices and within the process environment. And that really is going to take all of our facilities to the next level when we get each device replaced. But again, as you were talking about, each device in the field isn't going to have this capability. You need to actually implement devices, and there's device selection recommendations from the American Water Association or Water and Wastewater Association. There's plenty of resources from that standpoint as far as standards, communication methods, and it all is going to depend on your facility's existing infrastructure.
Right. It's, in simplest terms, I guess if you were to compare it, it's almost, for a wastewater treatment plant, we all have seen the ads for, what is that thing that, for the Alexa, do this, Alexa, do that. So it's almost like equipping your wastewater treatment plant with its own Alexa.
Yeah.
In the simplest of comparisons, if you were trying to make it easy for someone to understand what that would be about. So you had mentioned to me something about, as all of this was being developed, this smart technology, that obviously some standards needed to be developed for this. And you mentioned something about an industrial standards code that kind of sits underlaying all of these processes, whether, it's a PLC or a PAC, or what was that other thing you mentioned, a DCS. What do you mean by the industrial standards code? Like, who came up with that?
Well, so the International Electrotechnical Commission, or IEC, came out with 61131, and it's a set of publications that defines what a PLC is. It defines both from a hardware standpoint and a software standpoint. And it also defines the different programming languages that can be used within that environment. And those programming languages are in order of most used to least used within the field, at least from my experience and most people's experience. You have ladder logic, then you have structured text, function block diagram, and sequential function chart. And sequential function chart has a lot of good things to it. It's just not commonly used because it is a difficult language to program in. But ladder logic actually derives directly from what the previous implementation of automation was, which was relay logic. So you had physical devices in cabinets, large cabinets around facilities that needed a lot of automation, like power facilities, water facilities are good examples. But those relays would pull in or release based on the status of different field inputs coming from various devices. And we called that Industry 2.0. And Industry 3.0 came around with the advent of the PLC, or the PAC. And now we're moving into this world of intelligent design, data analytics, and into Industry 4.0. And that is such an exciting thing to be around right now.
Wow. So, I mean, it's one of these things where I hope that the audience anybody's watching, they can't see the glaze going up over my eyes, but it's it seems like the more that we incorporate technology, the easier it's going to be to control. Will something like this have data capture where plant operations facilities would be able to kind of look at things to determine, I guess you would call it predictive maintenance of, wow, this thing keeps going off all over and over and over again. Could that be a sign that maybe it's reaching the end of its life cycle, or we need to keep a better eye or take a look at something that might be going on with a particular element within a plant of having these kind of controls? Is that just like another layer that can help them with that?
Yeah, and as you mentioned with Alexa, it's like one of the primary things that you want to expect from your control system is to ensure that your operators are getting useful information. So when you talk about getting information from a device that flags a possible issue, you want to make sure that your system overall has good alarm management. Otherwise, you can get nuisance alarms that end up causing operators to start ignoring statuses that are coming in from a particular device or from a particular process area. And so the more data that you're getting from a device, you actually need to increase your data governance and your alarm management strategies in order to make sure that you are getting that usefulness at the operator level from the information that they're receiving.
So is that someone, that's a really good point. You were bringing up those nuisance alarms, and how is that set? Is that set from the operator side, or does that come from the actual equipment and software side?
That comes from both sides. And so
Oh, okay.
you have preset values for different types of alarms, whether or not it's an analog alarm that's coming in from a temperature transmitter of saying that the temperature is too high or too low, or if it's from a discrete device that's telling you that your level is low in your sump. Both of those conditions can have what we call nuisance alarm occurrences, where your sump discrete device is tripping, even though it's not in that particular state. You could be losing the input to the controller, and if you don't have what we call as a debounce timer for that input to drop out and come back, then you'll get anywhere from 20 or even more alarms per day or even per hour, depending on the instance. And that really drives this status from the operators to look at alarms without the same priority that they should. And that gets into the next level of alarm management, is you really need to have a robust alarm philosophy and alarm handling process where you're reviewing the number of a specific alarm, the number of alarms from different processes, and having what we call as first in alarm. So if you have a piece of equipment that goes down or shuts down,
Right.
then what your alarm management or your alarm system should be doing is it should be flagging the first alarm that came in, and all the other alarms should be suppressed from an operator review standpoint. And that's really taking your logic that you're writing within the controller or within your alarm management system to the next level from where they've been. And that comes into the tradition of what control systems were designed to do, was to make sure that status was read, and how you implement the logic has a very vast effect down at the end stream for the operator to be able to monitor that field status.
Okay. Well, just shifting gears a little bit, how can this kind of technology be successfully incorporated into a wastewater treatment plant, really touching on, automated process control, that remote notification without being annoying? Obviously, we just talked about that. And then following up with that data analytics. What's the best way to approach it? Like, let's say they have very nominal. I'm sure most plants have some of this in play, but
Right.
to now start thinking about a plan to go into almost like smart city style.
Yeah, I mean, that is what we're talking about here. We're talking about taking our facilities, and a lot of this will be driven, in the next few years from the asset management advantages. And what you were talking about with preventative maintenance is that's where you're going to get the biggest benefit coming back from implementing these types of solutions out in the field. And so a facility that implements a controller, whether or not it's a PLC or a DCS controller, but a device capable of running a user-written application in the field or on the edge, is going to get both the benefit of automating the process control. They're also going to get a benefit of the data collection mechanism and pathway that that establishes. And then they're going to have remote user or operator availability to be able to view into that system if they so choose. And so implementing these types of solutions into the field is going to bring us into the smart city type realm. And for many systems, it's going to start with skid mount. So you're going to buy a piece of equipment that's going to have a PLC on it in order to automate its processes internal to that piece of equipment. But the next level is going to be establishing the networks facility-wise to be able to ensure that the data collected from those devices, from that piece of equipment that allow us to do predictive maintenance, gets integrated into a central database, either for that facility or for that region, and then can be used for asset management type strategies.
Okay. So that leads us to one of the things, I guess, that prompted this was security risks for wastewater treatment plants and how to improve it. And we talk about security weakest links. I guess we didn't realize until back after 9/11 that our wastewater treatment, our water facilities really could be used as a weapon against us if they were attacked. But then it also gets not just from external forces, but you and I discussed about security links when it's an internal force of maybe an improperly trained person being able to make a change on something that they shouldn't be making, or someone that shouldn't have control over something. And so I want to dive a little bit into how this can be used for user access, designing of the network, and also advantages. You mentioned the term edge earlier. A lot of people are very afraid of this, cloud computing. How secure is it really? And then speaking to cloud versus edge and all of the security things that people need to be aware of as they're thinking about this technology.
Yeah, absolutely. Like, security is a priority number one that has come to exist within the operational technology world. If you go back to the initial days back in the 70s and into the 80s and the early 90s, all of the networks and bus networks and communications that happened between the controllers and the operator clients was mostly proprietary. I mean, Ethernet was not necessarily very widespread, so all of these vendors had to come up with their own methodologies of providing communication between these edge devices or the compute resource that was out in the field and the operator client to be able to interact with that system. And so user access necessarily wasn't a very big deal because proprietary networks are not very susceptible to malicious activity. They're just not as well known. You have to have direct access to a node on the system oftentimes to be able to implement malicious activity. But that's where, when we started to have connectivity between these systems that had proprietary networks on them and the general IT community itself, we're talking about this IT-OT convergence. We're really starting to open up ourselves to be able to have a malicious activity or malicious actor come onto the system and navigate through to interact with the system or to make it do things that you really don't want it to do. I mean, Stuxnet back in 2010 is one of the best examples that we have current date of what could happen with an operational technology system. So from a user access standpoint, we now have these credentials that are of typical operators that can be either stolen or spoofed is another term, where you're acting like you're a privileged user. And if the protocols don't necessarily handle that properly, then you could implement actions within the system that are not intentional of what the system is expecting. Sorry. But as you and I were talking about before, this isn't the only level of cybersecurity that we need to be concerned about. We need to also be concerned about of our training aspects as we bring in new operators, and our ability to ensure that they can only take actions within areas that they've been certified in or trained on. And that's one of the things that has to be built into the logic. So many times within a control system or a SCADA environment, supervisory control and data acquisition, is a user will come in and they will be classified as an operator, and they will have the ability to turn on and off pumps, change set points sometimes, or modulate a valve. But those users don't necessarily get classified per area. Now, some of the more recent code blocks, as we get better and better at modularizing our code into replicatable implementations, we can put in, we can leverage interactions between user databases and classifications where each user gets classified per area on their ability to do those types of actions within the field. And that's a level of cybersecurity that's not really talked about widespread, because everybody's focusing on making sure that the malicious actors aren't able to get in. And that gets into having your proper network design, making sure you're either segmented or separated from the internet, and that you have the right firewalls, and that you're maintaining proper user access protocols.
Now, you had mentioned a term, least privileged access. What is that, and why is this so important? And basically, how can a control system help you? It sounds like, from what you were telling me offline, that this is a really important function to have. It probably ties back into what you were just talking about, of making sure that someone who isn't trained doesn't have the ability to access things that they shouldn't. Or is it something completely different?
No, they are related, but then we move in from operators who we want to take a least privileged access approach, but we don't necessarily have the infrastructure of the code to be able to do that all the time. So your least privileged access implementations are always going to depend on the systems and the infrastructure that you have currently at your facility. So, but from an engineering standpoint, you also have oftentimes a limited number of users to be able to support these systems, and you have a wide breadth of number of systems that are required in order to actually provide these services at a facility. So if you're talking about even a small facility or a large facility, you have virtualization, you have networking switchgear that needs to have administration activities done and performed. You need to have configuration of those devices. You have field devices, you have the PLCs, you have operator interactions, and then you have all these software packages that are oftentimes still manufacturer provided, that all have different user levels. And to take an approach that is least privileged access, not only are you oftentimes limited on the number of professionals that you have for each one of these systems, but you're limited on the time capability to be able to do so and to implement those in a reasonable fashion to ensure that, one, you're not affecting the user, whether or not that's an operator, a mechanic, electrician, an engineer, from being able to do their job, but also making sure that they don't have the administrative type privileges to those systems that they don't need. And that's where the term least privileged access comes in, is you want to make sure they have the ability to troubleshoot in the situation where they need to, but they don't have the access from a typical username as far as their credentials are concerned, from performing actions that are not part of their daily jobs or part of their weekly jobs or part of their roles and responsibilities. And that leads to a lesser impact when you do have a compromise of a user account.
Okay. Well, these are all things that we need to take into account as we're moving forward with embracing, or hopefully embracing, more and more technology to help us do our jobs better and help to make our systems more secure. And so I want to thank you for sharing your knowledge about this. Now, tell us a little bit about what IT/OT does in relationship to the subject matter we've just been discussing.
Yeah, so IT/OT Systems was founded by myself about a year ago. to provide consulting services to both municipalities and private entities on this subject matter. I mean, I have 15 years experience doing this at both small and large facilities and advancing their technology footprint to the point where they have implemented robust systems that are handling this with good practices and sometimes even best practices. So from a network design standpoint, from making sure that your systems are leveraging least privileged access procedures and policies. And then you have the standards approach that you can bring in from a security standpoint, whether or not that's NIST, or if you want to use ISO 27001. We are familiar with all of those different genres across the board from a control system standpoint, all the way from virtualization in your data center to the end field device, to make sure that you have the data pathways that you need to be able to do that predictive maintenance and predictive analytics and provide good asset management at the end of the day.
Excellent. So if people want to learn more about what you do and the things that you bring to the table, tell them where they can find you online, your website address.
Absolutely. Website is itforot.com. That's the number 4. And you can email us at info@itforot.com. And I would love to help you out with taking those next steps to becoming a smart facility.
And you can also connect with Greg on LinkedIn. And in the show notes below is his LinkedIn link, and he welcomes connections. And I hope that the audience, you've gotten something out of this today. I know it can often be, technology can be a little bit of a dry subject, but I think it's something that we need to examine as we move forward and as we grow. And of course, security always being an issue and removing as much human error as possible. And so, Greg, again, thank you for being on the show. And for those of you, thank you for tuning in. Until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.